Hello, everyone. I am recording this right before Thanksgiving break, so I hope you all have a good Thanksgiving and get a chance to watch this following the break. But until then, enjoy your time off. And then in this lecture, I'm going to be talking about some do's and don'ts of data visualization. So this is something I've sort of alluded to a few times, given a few pointers here and there, but this is sort of my synthesis of several things that I have learned over time and thinking about this as we all, as scientists and engineers, produce graphics, and it's important to think about what we are producing and if we can make them better. So all things even, I have to give major shout out to Ben West and Jen Stair from Laura Condon's research group. They have also done a really nice presentation for the research group in a group meeting, and they let me pull in some of their slides. So thank you to them and for letting me use their slides. Thank you for them thinking about this deeply as well, and let's jump into it. So I'm just going to, motivate this whole thing about why it's important to think about this with a bad example. And we like that because we love to dunk on things. So here's our bad example. It's National Review tweeted this out since deleted because it's not a great look, but they say the only climate change chart you need to see is this terrible Excel graphic, which purports to show that the annual average global temperature has not changed in the period from industrialization to the time it was tweeted. And there are a number of bad things about this. First of all, it is taking data and being misleading with it under the guise of being informative by showing basically, they start their graph at 0 here on the y-axis, and they go all the way up to 110 without showing sort of the actual range of the data so that you can see if there's any trend there. And, their whole thing is that the global annual average temperature has not changed in that time. So this is, they have basically chosen their data visualization to support their claim rather than understanding the data and using effective visualization to show what the data actually explains. So those are some reasons that why this is bad. It was them trying to take a data set and make it sort of support their claim by visualizing it in a dishonest way. So how about an example of a better visualization that basically shows the same data set? It goes to a little bit more recently, but by looking at the trend, so the difference from the average over a long period of time, we can actually see warming, in fact, is occurring. And this is actually what the data says when you show it in a way that's consistent with sort of the data range and transforming it in a way that makes sense for the thing that we're actually concerned about. We're not concerned about whether it's 55 or 60 degrees Fahrenheit on average. What we're really concerned about is this changing over time? So making sure that you display your data in a coherent and deliberate way is a great way to get your message across in an honest fashion. But bad visualizations can also take away from the data. So, when we think about data viz as like a field, which is short for data visualization, you'll kind of tend to be pushed into things like infographics. And so I just grabbed some generic infographic from the web that doesn't actually show anything, but it is sort of indicative of sort of some of the hype train that came along with data viz as a thing within the last 10 or so years. And this uses things like complex symbology, where there are these symbols that you're supposed to interpret in various ways, and they show up all across the chart, and you're supposed to be able to link them to something. They show these like unique breakdowns of data. Of course, this is all a meaningless one, but you know, again, the fact that someone created this is like, this would be a cool way to visualize data. And so there's like these unique breakdowns that you know, like I don't necessarily think that this cube thing is actually going to add value to showing how the data actually tells a story. And, you know, they'll put in flowcharts everywhere because flowcharts are a good way to show something fancy going on. And if it's got a flowchart, it must be fancier than it probably needs to be. And then finally, like they'll just put circles everywhere. And, you know, by the time I point this all out, my critique of this ends up being just as messy as what I would say this infographic is. It gets muddled, it's confusing. The messages aren't clean, clear, and simple to understand. They might look cool or something like that, but really in data viz stuff, you know, you can go a long way by removing a lot of that complexity to get your key points across. So here's another sort of, this is a real world infographic thing. It looks cool, right? Like we like to look at this. It's showing injuries in American football and where they occur on the body. And so, you know, they kind of put the circles where they are on the body and then talk about the numbers of them. But really, if I was to ask you at a glance, you know, which are the top 5, it would actually take you a while to like hunt and peck through. And, you know, you might be able to identify knee as the biggest and ankle as the second biggest right away. But after that, it becomes very difficult. And so that's not really a super easy way to, you know, get your message across. What would be more effective is a simple plot, a simple bar plot. You can see they are ordered by the total number. You can easily scan this and see this. There's not actually a ton of value added by putting the knee data point on knee because we all know where that is. And further, these circles are very, very hard to actually cross compare. Is this arm with 9 actually like 30 times smaller than knee, which is 300? You know, like how does proportionality of this graph actually scale? Whereas here, this is actually proportional in a way that your eye can make sense of. The eye is like a really good statistical tool when it comes to actually comparing things when they are presented in a consistent way. But when they're not consistent, it can be very difficult to cross compare things. And so using a simpler chart here gets the data across much more easily and doesn't hide the relationship between them. And what I would say is most effective data viz looks more like these things, where these are all very simple graphics. For example, this time series where it doesn't matter what any of these are, but you can see there's a rising trend for one of them kind of flattens out, and then one of them, you know, you can easily cross compare these things. You can see in the heat map here that there are certain areas which are darker. This is COVID cases for a particular snapshot in time. So you can easily see the red pops out at you. You can easily see this place or that place. The scale of the color map is proportional to the actual data that's being shown. Things like box and whisker plots show easily like how well distributed your data is, and can convey a sense of whether or not something is inside or outside a confidence bound. So this blue box here is outside of the target of 0, which is being shown with the horizontal 0 line there. Things like simple flowcharts, they're not pretty. They don't need to necessarily be complex and use all of these symbols and typologies and things. a simple flowchart goes a long way to conveying what you are trying to do. So this is the flowchart for the Snow 17 snow model, which is widely used in snow modeling. And then, simple bar chart, nothing wrong with a bar chart either. This just shows a distribution of elevations across a particular domain. And so these very simple data viz techniques actually get you a long way. And one moment here. Okay, sorry about that. But again, simple data visualizations that really convey the point and don't try to hide your data are really effective ways to get your point across. And to that point, visualization is it's a form of complex communication. And so choosing the right way to visualize this is really key to being able to convey what you want someone to take away. So let's start with this example that's pretty classic. If I show you this set of random digits, how many sevens are there? I'm not going to make you actually count this through, but the point is, you're scanning this and you're finding it very hard to find all the sevens. They don't just pop out right at you. And maybe a more effective way, if, for instance, in this trivial example that you wanted to show this, you would use something like color to differentiate, or the contrast to differentiate and show. You can immediately pick these all out now. Now, counting them up is still a little bit of a challenge, so maybe that's not the most effective way to count them, but this actually shows where they are and makes it very easy to pick them out. So this is a step in the right direction there. And this is intuitively quite easy to see here, because this is a contrived example that has been designed to illustrate a point. But how does this actually work? How do you know, for instance, with different types of data, what sorts of visualizations you should use, and how do the elements of visualization actually work? So there are basically 4 main ingredients that kind of can be used in your data visualization to lead people to see what your data is showing and let them see it clearly and intuitively. You can use shape, color, size, and finally location. And so for each of these, I have a very simple example. This is shout out again, Ben West and Jen Stayert for succinctly sort of summarizing these ideas. So location is just, if you have some points, they just go where they are, and they're proportionally, you can judge distances, you can judge trends and things like that quite easily from these types of data points, where their location is clearly mapped out and mapped to some sort of numeric values that are visible, or similarly, they can be categorical. For instance, this could have been, some range of categorical or nominal type of data. So location is an obvious one, that where you put your data in relation to other data points paints a message that tries to show the relationship between them. Color similarly shows a way of sort of differentiating between multiple classes of data or multiple categories of data. So here we can see that, there's a blue set of points and a red set of points, and they're distributed differently. The blue set of points, it looks like they're more dense over here, and the red set of points is a little bit more dense over here. And so these are things that your eye sort of naturally picks out. And you can also see that there's maybe more outliers with the red points than there are with the blue points. And these are things that, you can use not only to communicate with the wider community, but you can also use this as sort of a way to explore your own data, as we've been doing. And so this is sort of a rule of thumb, that if you can find effective ways to visualize your own data, you can pick out things like this more easily. Finally, shape, or not finally, but shape next is laying out. So there are different sort of symbols that you can use, a circle, a square, or a diamond, and those would differentiate different types of data. And so here you can see Canada and China have much less blue dot than South Korea, but on the other hand, China has more red diamond than Canada or South Korea. And so this is a way to differentiate different types of data, which say different things. So if there are multiple categories within multiple categories, for in this case, there's 3 different symbols within 3 different countries. That's sort of like a 3 by 3. There's 9 different options how you would show that. And then finally, size is quite obvious here. Sorry about that. Size is quite obvious here, where the smaller points end up down here and the larger points, and you can kind of see proportionality. I will say one caveat to this is the human eye is not good at judging area of circles, so using that carefully is important. However, but you can still use larger things to emphasize more importance or more something or another. It is one of the fundamental quantities that can be used. And there are many ways to sort of arrange these 4 basic components to highlight different things. So for instance, you can easily pick out this sort of diagonal line here based on its sort of shape, and same with using the square or things like that. So these are a bunch of ways that you can use either shape, emphasis, or size in a way that that tells you something. Same with color. There are multiple ways to do this, using intensities or hues, and then again spatial positions. So there are many ways that this can be combined to highlight or emphasize different parts of your graphics. And so there's a link down here which goes into this in much more depth that you might check out. So since I've talked about some of the fundamental sort of pieces of how data can be visualized and what they're useful for, I'll take a moment just to let you look at this graphic and let you decide, first of all, whether or not this is a good graphic or a bad graphic. Okay, so I've given you a little bit of time to look at this, and I'll go ahead and give you my analysis and also a little bit of summarized from Ben and Jen. And first of all, no offense to the National Renewable Energy Laboratory who produced this, NREL, but this is a bad graphic. It's very complicated. It's hard to look at, and it's hard to intuitively understand what it's trying to say. First of all, they hit you with, like, probably the very first thing when you scan this over, you see all of this, like, this is where the data came from. And it's like not entirely clear whether or not this is useful information. Like Arizona 2003, that's when it was updated, I guess, but from what? I don't quite know if that's useful or not. It's hard to tell. It's not like any of these years are like drastically different from each other. So to me, it's just extraneous. The color map is not intuitive, actually. Like if you look at this color map up here, you probably would not choose this red value somehow to be between the purple and the blue. That's just not how our brains interpret color. These two should be swapped, and then it would make more sense because that kind of follows a linear path through the color space. So that's not a good color map. And similarly, the color map for the transmission lines, which you probably didn't even get a chance to look at yet, is also not good. These green lines pop out. These brown lines, can't see them anywhere. This one isn't even following a color scheme. It's got 2 lines. It's inconsistent. it's all over the map. Also, there's two greens, but they're not next to each other. I don't quite know what to make of like what their decisions were going on here. Again, you can see I don't like this map. You just can't disentangle it. And finally, like, why are there so many legends like strewn about? Put these all in one place. And so to NREL's credit, I've gone far beyond where I meant to. Let me get back. Okay, so back here we are. Bad map. To NREL's credit, they have since updated this in a way that makes much more sense. So NREL has redeemed themselves. So this is mostly good. The color map follows a clear progression that you can easily see things in the data that pop out. For instance, you can see mountain ranges pop out, which is intuitive to your head. Same with drainage channels and things like that. And you can start to think about how that sort of elevation would affect wind resources, and it's very clear to draw some inferences from that. The legend could be a little bit easier to read. It's a little bit messy and a little bit kind of tucked away in the corner. I wish they could have made it bigger or easier to actually, these ranges are a little bit complicated. They still put Alaska and Hawaii on the map, even though there's no data. They could have just put that in a asterisk up here. And then finally, like the state boundaries and names are a little bit hard to read. But, you know, all things considered, this is a nice map. Things make sense. And so this comes down to, in these two cases, color choices are actually important. And so there are many ways to think about this, but accessibility is actually a really big part of this. So, and we have to start down at the bottom. There's this classic color map called JET, which is this, like, it's really appealing, right? It's this rainbow. Your data looks colorful and really nice to sort of like, it's visually pleasing when you plot your data this way. But for many reasons, it's actually not nice. So first of all, this yellow color and this sort of cyan, like teal blue, they actually jump out more to your eye because they're actually like more luminous than the other colors. And so you see this especially for the 1 in 20 people who have some sort of color vision deficiency, as described by these 3 different sort of broad categories, and sort of what these color maps simulated would look like for someone who experiences the world this way. And you can actually see these things pop out just as easily here. So there's, again, these sort of spikes in brightness that actually kind of would highlight things that your data you don't necessarily want it to. And furthermore, for full grayscale, there's sort of these 2 ends wrap around to each other, and so you can't tell the difference between these 2 types of these 2 extremes of data, and that's actually really bad. You don't want people to confuse a high-end extreme with a low-end extreme. That actually can have real impact in people's takeaways of your data. And on the other hand, there are newer color maps, which probably in the last 10 or so years have started to become more popular for these reasons. Things like Viridis, which is sort of the sequential color map of choice in Python. Cividis, I actually don't know how you pronounce this in spoken language, but the sort of blue to yellow one. This is the default now in MATLAB, and there's a bunch of other ones. There are people come up with color maps that do this all the time. There's one that I really like. That's a replacement for JET when you really do want rainbow sort of colors, but you don't want this this sort of colorblind unfriendly sort of thing. There's one called Turbo that is really nice. And so when you actually look at this, these have very clear orderings across each of the different color blindness types, and even map into full grayscale. So if someone prints out your manuscript or your figure, they can still read your figures. And that's actually a really nice thing, because for reviewers, people often print them out because it's much easier to mark up a printed out copy. So choosing your color map is not just a matter of taste, it is a matter of accessibility. It's a matter of communicating clearly so that you don't have these bright spikes in ways that your eye naturally picks them out when they aren't actually significant in your data. And so just to kind of highlight this point, besides those few color maps, if I give you this color, map of major US watersheds with these sort of 4 picked out, and you look at this with a couple of those different colorblind sort of simulations, in the lower left here, you see that this still kind of works out. It's still fairly easy to pick them apart. But in the lower right here, the Northwest, the Columbia River Basin, and the central US, the Mississippi River Basin, are just basically indistinguishable. And you can imagine this gets even worse in things like presentations, where the projector already has a hard time maintaining things like color contrast. So we can do this again. This time we've got a few more. And so as you add more and more categories to your data, it becomes even harder and harder to maintain this sort of color consistency unless you're very careful. So here we have this broken down even further into sort of smaller watersheds. And again, in the lower left, you can mostly pick them apart, but in the lower right, it becomes, even more difficult yet again. So these are just like practical examples of how this actually bears out in the real world with real data, rather than just showing the full extent of your color maps. And so I want to return to a point, now that you've seen how you can use different sort of visualization elements, and how things, how like choosing the right color map matter. I want to return to not just like the how of data viz, but the what and the why. So I'm returning to this NFL injuries example from the beginning here. And I just want to point out, like, it's like, yes, the knee and the ankle are the biggest ones, and those kind of drop out really easily, and the arm kind of as the smallest, but all of the rest of this, kind of becomes a little bit muddled and jumbled apart, and you might not be thinking about what this actually means and what are the takeaways. You just kind of are forced into the ordering that was given to you in the visualization. And so maybe when you're doing your own visualization, don't always show all of the data. Show the data that makes sense for what is important to the problem that you're trying to highlight or solve or have explained. And so in this case, head and foot have the same sort of magnitude, but are we hiding a bigger problem by putting them on the same level? And that's something that's always a question that you have to ask yourself. And in the case of this visualization, I'm sure they've talked about it, but ended up saying that these two things, all things considered equal, were equivalent for what they wanted, the point they wanted to make, but perhaps is not the point that you yourself would have wanted to make. And so it's important to think about conveying the message you want to effectively by showing data in a way that is commensurate with the impact that it has on the types of problems that you want to solve or highlight. And so I'm going to just, at this point, drop quite a few links here for things that you should check out, and I'll go through each of them very, very briefly. Color Brewer is a really nice sort of interactive way to come up with some color maps for different types of data. So you can choose different types of classification, like the number of data classes. You can figure out if they should be diverging. That would be something like with the temperature anomalies. You want to show below average or above average. And you can show quantitative or qualitative, which are different types of categories. And they show it on this nice little map here. You can choose options for like colorblind safe, and you'll see as you do this, it's very easy to come up with sort of data categories that just don't have a clear solution. So this is a great way to explore some options for choosing different sort of color categories along different data types, like sequential, diverging, and qualitative. Similarly, there's this really nice tool from Sasha Trubetskoy, which is just a list of 20 distinct colors. They give them all right here, but the really nice thing about it is you can choose between ways to sort of pull them out in sort of put them in range of like different contrast levels, or choose your level of accessibility. So you can filter this down. And so like if you want full accessibility, there's these 5 that are going to work for almost anything. And so you can just grab these right out of there. Next up, there is from David Nichols, this really nice set of ways to simulate color blindness and other forms of accessibility sort of concerns. And then it's all interactive. So they give some examples throughout this and give some sort of, again, color palettes. But in this case, you know, it's again really interactive. So I can go ahead and start to add colors. So if I wanted to add this sort of, I don't know, kind of grayish pink, you can add that in and it will show you across all of these different sort of color blindness options. And so this is a great way to test out different ones if you aren't happy with those from Color Brewer or the list of 20. You can go ahead and actually put this in here and check those out. There's this also really nice site which you can basically download the software, which will tell you about whether or not you have enough color contrasts to make your text or your visualization easy to actually understand. And this is something that, like, I'll even throw this out there. There's a lot of websites that use very, very like thin fonts and things that are just really hard to read, and they could use a check through on this. So this one you can use sort of more free form than the others. This would be a tool that you would download and use elsewhere. And then finally, we talked a lot about how, like, what are the key quantities of visualization. But there are also, you know, there's all of these different chart types which already exist. And so you might want to look through this this document, which talks its way through the ways in which you can map your data by thinking about what you're trying to encode with the actual visualization. So how do you choose between a bar chart versus a time series, and things like that? And like it goes even further, like this is the bar chart, but it's based on deviations and using different colors across a central axis to show those. So this is a really nice little walkthrough of choosing these basic chart types for you. If you're not quite sure the best way to use things that pre-exist with your own data. Okay, so that is kind of the last piece of this lecture, and that brings us to your assignment. This is going to be relatively straightforward one. I just want you to find one good example of a data visualization and one bad example. This is entirely up to your own judgment. You can be very basic in it and sort of pick ones that are really straightforward to find. You could try to be a little bit controversial and pick ones that you think would stir the pot a little bit. It's entirely up to you. I want you to add both of them to your homework repository, and don't say which is which. I don't even want to know which ones you think are good or bad. And then I'm going to compile this into a slide deck, and we're going to walk through this in class, and we're going to have a discussion about which ones are which. And we'll see whether we all agree or disagree. Because again, this is a matter of taste, and it's something that you sort of will develop your own sense of how to find and understand graphics, and then further take and make them based on your own data. So this will be due on Thursday when we're back from break. So all you have to do is upload them to your homework repositories, and that is it. I will take it from there. Okay, thanks for tuning in and watching.